Hi, this is Mr. Rubenstein, and this is the third part of a series of tutorials on how to calculate a good approximation of pi using Archimedes' method. Where we last left off, we had figured out that the length of AD was 0.13397, and that gave us an approximation of pi. Was the perimeter of this 12-sided figure, which is 3.21539. Now the goal is to bump this up from 12 sides to 24 sides. Now to get the length of half of one side of the 24gon, that's calculating the length of AE. Now we already know the length of AD is 0.13397, and we know that AO is 0.5. And we also can calculate out the size of OD, which we're going to need. You could use the Pythagorean theorem, 0.13397 squared plus 0.5 squared, and take the square root of that. And OD is going to have a length of 0.51764. We're going to use these things in order to calculate out the length of AE. And once I have the length of AE, I'm going to multiply that by 48, and that's going to give me an even better approximation for pi. So to calculate out the length of AE, which would be half of one side of the 24gon, we're going to use facts that we already have, which are that AD, this entire length over here is 0.13397. AO is still, as always, 0.5. And OD I calculated out using the Pythagorean theorem, because this AOD is a right triangle, to be 0.51764. Well, if I call AEX, since that's the thing I'm trying to calculate, then DE will be 0.13397 minus X. And the angle bisector theorem says that I can set up this proportion to solve for X. OD over AO, that's 0.51764 over 0.5 equals ED over EA. Well, ED is 0.13397 minus X, and AE is what I'm trying to calculate, which is X. When I cross multiply, I get 0.51764X equals 0.066985 minus 0.5x. Add the 0.5x to both sides to get 1.01764x equals 0.066985. And when you divide both sides by this 1.01764, you get an answer for X is 0.06583. Now X is AE, which is exactly 1/2 of one side of the 24gon. So if I multiply X by 48, I get an approximation for pi, which is 3.15966. And this is a very nice approximation for pi. But he's not done, because now he's going to do this process 2 more times. Now that he knows the length of AE, he can move this up to a 48 gun. like this. The side of half of one side of a 48 gon is what I'm going to call AF. And he's going to calculate this out again using the angle bisector theorem. He knows that AE is 0.06583. He knows that AO is 0.5. OE you can get with the Pythagorean theorem, and that ends up being 0.50431. Well, knowing those three sides enables us to calculate out this tiny length of AF, which I'm going to do on the side. So here's an enlarged picture of that triangle. AE is 0.6583, so if I call AF x and FE 0.6583 minus x, Pythagorean theorem gives me that OE is 0.50431, and now I'm going to use the angle bisector theorem. I have here the proportion 0.50431 over 0.5 equals 0.06583 minus x over x. I cross multiplied. I move the 0.5 x over to the other side. And finally I divided by both sides by 1.00431 to get the value of AF to be 0.03277. Remember, that's 1/2 of the side of a 48 gon. So I'm going to multiply that number by 96 and get our approximation of 3.14609. Now, as you can see, I have the first three digits of pi here. Well, he's going to go one more time, and I'm going to take you through the calculations on this. So he's calculated out AF to be 0.03277, which means the perimeter of this 48 gon is 3.14609, but he's not going to stop there. He actually isn't going to stop until he shows that it's slightly less than 22 over 7. And that's going to require him to go one more step and to increase the number of sides to 96. Now for 96 gon, he's going to need this very small length AG, and I'm going to take you through the calculations on AG to get AG right now. Then we'll multiply that by 192, and that will be good enough for his purposes. So I've enlarged this picture here. AF was calculated to be 0.03277 from before. Using the Pythagorean theorem, you can work out FO to be 0.50107. Now finally we're going to calculate out AG, which we're going to call x. That makes FG 0.03277 minus x. Angle bisector theorem says that I can set up this proportion 0.50107 over 0.5 equals 0.03277 minus x over x. Cross multiply and get this equation 0.50107x equals 0.016385 minus 0.5x. Add 0.5x to both sides to get 1.00107x equals 0.016385. And when you divide both sides by that 1.00107, you're going to get our value of x, which is AG, is approximately 0.01637. Now this is 1/2 of one side of the 96 gon, so I'm going to multiply that through by 192 and get 3.14271, which is where Archimedes is going to stop. Archimedes has accomplished what he wanted. He wanted to show that the circumference of the circle was less than 22 over 7. As you can see, 3.14271 is less than 22 over 7. That's our familiar value approximation for pi, which is 3.1429. He actually doesn't stop there. He stops this approach, but then he does this exact same thing again, or he does a similar thing using polygons that are inscribed inside the circle to get that pi also has to be bigger than 3 and 10 over 71.